Okay, Tyler, and you can start, and I'll mute myself.
Okay, sounds great. Thanks, Lev. Okay, well, I think everyone on this call probably knows me, but I'm Tyler Williams. I'm a data engineer and data architect. Let's see, today I'll be talking about comparison of SQL Server variants, although that's probably a little more simplistic than what this discussion will really entail. I'll be talking at a high level first about some SQL Server variants that are available, and then going into a little bit deeper discussion about OLTP versus OLAP, and things like that. But yeah, talking about this, it used to be before cloud platforms really took off, the only SQL Server variants that people would be concerned with are whether you're running a enterprise edition or standard edition of your on-prem SQL Server. And sometimes also you'd think about potentially the Express edition or developer edition, things like that. But the whole landscape for SQL Server has grown quite a bit since cloud computing has really taken off. And so I'll be talking a bit about some of those variants. So jumping right into it, some of the current flavors of SQL Server that we have today. If you're dealing strictly with your on-prem versions of SQL Server, the latest generally available version of it is SQL Server 2019. So that's what you would install on your on-prem hardware if you have that version of SQL Server. And then all the remaining versions that we'll be looking at are all based in the cloud. So the next one on this list you can see is running SQL Server on Azure VM. And then there's a SQL Server managed instance. That's a let's see, platform as a service. And then you have Azure SQL Server DB, also platform as a service. Sometimes Microsoft will also refer to it as database as a service, so the DB as. And then we'll also talk a little bit about the Azure Synapse dedicated SQL pools, which is a parallel data warehouse, and the Azure Synapse serverless SQL pools. So getting a little bit more into this, you can see highlighted now on the screen, those first four are what I'm going to be referring to as more traditional SQL Server. These are the more your transactional SQL Server databases. And so after an initial comparison between these four, the remainder of this talk, I'll be focusing more on kind of those the differences between those collectively and more of the analytic versions of SQL Server and the Synapse analytics. So if we look at those first four, you can see this kind of shows the various costs and how much support and administration is required on the part of the IT team. So you can see with the physical server installed on-prem, the team responsible for managing the SQL servers also has to worry about managing all the hardware on which it's installed. And so you can see on these axes here the level of cost involved, as well as the level of administration on the horizontal axis. So really, of course, when you have an on-prem installation, you're responsible for everything. You have a lot of upfront cost in terms of investing in all of the hardware on which you're running your SQL Server, and you're responsible for all of the maintenance and administration of that hardware, as well as all the software running on it. And so if we move up, the next version is the SQL Server on a VM, on an Azure VM. So the virtual machine is hosted in the cloud, so you don't have to worry about maintaining any of that physical hardware. All that's taken care of for you. It's just on a virtual machine. But beyond that, you do have to worry about all of the maintenance and updates of any of the software. So the Windows Server software, the operating system that's running on it, as well as any patches and upgrades for the SQL Server installation. And then let's see, as you continue moving up and to the right, then you have the Azure SQL database and your virtualized databases, where you don't even have to worry about the server software on which it's running. All of that's managed for you, and all you have to think about is just any of the objects and functionality within your database itself. So a little bit further comparison here between these traditional SQL servers, the more transactional SQL servers. I have a chart here kind of showing that there really isn't much difference at all between your on-prem SQL Server and your SQL Server on an Azure VM. And so this is your infrastructure as a service, the IaaS, because really the only difference between these two is the physical hardware. On-prem, you have to maintain the physical hardware. In the cloud, you don't. But everything else is going to be identical. And then moving to the right here, your next option is the SQL Server Managed Instance. And so this has nearly 100% feature parity with the on-prem and the SQL Server on a VM, because you're running, you are effectively running a SQL Server instance with one or more databases on it, and you have all that server functionality that you would get. You just don't have to worry about the OS in this case. And so you get a lot of that server functionality like SQL Server Agent, SQL Server Integration Services Catalog, cross-database queries. So if you have multiple databases installed on your server, being able to write queries with the three-part naming convention, including your database name when you're referring to tables. And then you also have things on the server like DBmail, and you can run common language runtime. So for anyone unfamiliar with common language runtime, that was a feature that was added to SQL Server that allows you to write code in a .NET language like C# and be able to compile that code and save those functions to the server. And then you can run those compiled functions within SQL Server in your SQL code. But behind the scenes, it's actually running that .NET code. So you can see with all these features, yeah, there's nearly 100% feature parity. I do have the little asterisk here for the SSIS catalog because the managed instance doesn't run SSIS packages natively, but it stores those packages on the server, and then you can execute them using Azure Data Factory or Synapse Analytics. And then finally, we have the Azure SQL DB, which is the PaaS, Platform as a Service. And so within the DB itself, you have nearly all the same features that you would find with on-prem, but really none of the server features, because really the server, when you create an Azure SQL DB, is really just a logical construct that is used primarily for the connection string to be able to connect and log into your database. So you won't get a lot of those server-related features with Azure SQL DB. But yeah, within the database itself, you get all the T-SQL functionality that you would expect. I have a couple links here for further reading if you're interested. Now, moving on to some of those other variants that I had discussed previously, we have the dedicated SQL pool in Azure Synapse Analytics. This slide may be familiar to any of you who saw a previous presentation where I was talking about Synapse. So yeah, just bear with me if any of this does look familiar. But yeah, with the Synapse dedicated SQL pool, it's a little bit different because its compute power is distributed across multiple nodes and several distributions in those nodes. So you have 60 different distributions. And so any operations that you're running in this SQL pool are going to be run in parallel across these 60 distributions. And so the data then also is going to be dispersed across these distributions as well. So as your operations are running in parallel, each one will be operating on different rows within your table. And then finally, we have the serverless SQL pool, which also runs in Azure Synapse Analytics. But this is strictly compute. It doesn't actually store any data. And really, it's designed to be able to run T-SQL queries and do analysis on data that might be in a data lake, for instance, but having that familiar SQL Server type interface and being able to use the T-SQL language for running your queries and doing analysis. So moving on, I want to talk a little bit and kind of separate these different variants out into the Synapse dedicated SQL pool. So I'm not going to really focus on the serverless SQL pool. It's a little bit of a different beast altogether. But really the dedicated SQL pool, which is that one that runs on the 60 distributions, versus what I'm calling the traditional SQL Server, which really covers on-prem up through the Azure SQL DB. So any of those initial variants that I discussed in this presentation. And so yeah, I'm just calling those traditional SQL Server, primarily because those you can across all of those databases and all those variants, you can use standard T-SQL that's been available for many years now. So in breaking it down, those traditional SQL Server variants would fall under what I would call online transaction processing, so OLTP. And so for those of you unfamiliar, OLTP is more sort of that traditional type of database that's used for like as a backend, typically for various applications. And so OLTP is optimized for processing individual records, or it's kind of smaller groups of records at one time. So some examples might be banking applications and maybe ERP software for managing your warehouse in a manufacturing type scenario, or even the database running behind a travel website when you're trying to book a vacation. So as you're doing these, interacting with these databases via the application, your individual transactions are being applied behind the scenes, and it's usually one record at a time or small handfuls of records that are interacting with each other. And then the structure, the schema behind the scenes is typically normalized data. So that means the various entities and attributes that are being stored are going to have their own tables, and they're going to have their own keys, and then you're going to have relationships, like foreign keys and things like that, to determine how the various tables are related to one another. And the primary reason you want to have these foreign keys and these relationships well defined is just because of the transactional nature and the way you have really these individual records being inserted, updated, in some cases deleted. You want to make sure that any keys that you're referencing in other tables always exist. And so that if you're modifying your data in any way, you don't want to leave these orphaned records where you have a key that references a record in another table, but then that table or then that record in the other table doesn't actually exist anymore. And so foreign keys would prevent that type of scenario from happening. Also, in OLTP, the way data is stored and indexed is really focused more on individual rows to be able to find single rows quickly and be able to modify them, very quickly and efficiently. And then, of course, as you would guess from the name, all of the data manipulation is structured around transactions, so that if you're reading or writing to or modifying data in tables that are related to one another, if you have a failure anywhere along the way, then that entire transaction gets rolled back and you maintain the data integrity in the database. Now, this type of system is in contrast to online analytical processing. So this is a different approach to databases that's really optimized more for reading and aggregating large sets of data. And so, as opposed to the normalized structure of OLTP systems, this data will generally be more denormalized or flattened out. So rather than a lot of records that are related to one another, you'll have that data joined into a single record in a single table. And so it introduces a lot more data redundancy. But since storage is so cheap, we're not really concerned about that redundant data because really the focus on OLAP is being able to read that data quickly. And then also, since we are doing usually a lot of aggregation, the way data is stored is in a columnar format, a columnar format rather than row-based, just because we're not typically concerned with identifying individual records, but we're looking at records on the aggregate. And so this columnar storage really facilitates those aggregations and the type of analysis that we'd be doing in these types of systems. And then likewise, typically when data gets loaded into these OLAP systems, and specifically thinking about something like dedicated SQL Pool in Azure Synapse Analytics, you'd normally be loading data in batches and not transactions. So, in other words, you'd be taking large sets of data and doing, loading and processing of a lot of data at one time, and not necessarily having to have individual transactions relating to single records where you have to maintain data integrity. Not to say that data integrity still isn't very important, but just the way the data is processed loading into these types of systems is quite a bit different, so that it's not really transaction based. And so, as I mentioned, yeah, these dedicated SQL pools really fall more into this type of system. So now I'm going to talk a little bit about some of the differences, some of the major differences that you'll see between these Synapse dedicated SQL pools and, again, what I've called traditional SQL Server, those transactional SQL databases. And I want to just address up front, why would there be any differences? Why can't we just have feature parity with the more traditional transactional SQL databases? And that would be really because the architecture underneath and how these database systems are designed are really vastly different. So even though they are both designed to utilize the T-SQL query language, the way that those queries run under the hood is really going to be very different. And that's all due to the fact that there are these 60 distributions. So again, this from a couple slides ago, showing the way data is distributed and processed in parallel here in this diagram. So, so that being said, there are a lot of features and functionality within T-SQL that has been created and designed with the transactional SQL Server in mind, that really just doesn't lend itself well to this distributed nature of the Synapse SQL pools. And so in a lot of cases, it's very difficult or even impossible really to implement these features and certain functionality within T-SQL. Just as an example, some things like identity columns and merge statements were initially not available in the Synapse dedicated pools, and particularly in the prior incarnation of the dedicated SQL pools when it was called Azure SQL Data Warehouse. So this functionality, though, of identity columns and merge statements has since been implemented, but it's a fairly recent addition. And I think it just really further illustrates how it's not necessarily a simple matter to just port this functionality over. So some of the data types here that I just wanted to point out is that a lot of the common data types that you're most likely to use are supported in both types of databases. Your traditional SQL Server, which of course again includes on-prem SQL managed, Azure SQL managed instance, and Azure SQL DB, and then as well as the Synapse dedicated SQL pools. So things you can see here are like your various string data types, date data types, your numeric data types, including your int, float, decimal, and whatnot, as well as binary data types. But there are some more specialized data types that you'll find in SQL Server that aren't in the SQL pools. And those include things like the XML data type, geometry and geography, images, a table data type, and also any user-defined types. So those, you can't use any of those in the dedicated SQL pools. And then talking about common or column constraints in Synapse SQL pools, I talked about foreign key constraints in OLTP systems and how you really want to maintain that referential integrity between tables. But in the Synapse SQL pools, foreign keys are not supported at all. And generally, that's not as big a concern in the type of system that the Synapse SQL pool is, because with it being more an analytics system, typically you'll have a different model. As I had mentioned previously, you'll have more of a flattened out table schema. And so, for instance, you'd have maybe a Kimball model, which is a star or snowflake schema. And typically you wouldn't really necessarily need the foreign keys anyway. I know personally, even before building a lot of solutions in Synapse dedicated SQL pools, even when I was just using regular SQL Server, I tended to avoid foreign keys anyway in a star snowflake schema, just because there is a bit of overhead when trying to do operations on tables. And then the fact too that a lot of the logic for ensuring that you have the referential integrity between your fact tables and your dimension tables, it's all managed anyway by any of the ELT processes that you would use to populate your facts and dimensions. So generally, those have been avoided in these types of models. And then in Synapse SQL pools, also some other column constraints that you'd encounter are primary keys and unique keys. And these are only partially supported in Synapse. You can define a primary key or a unique key on a particular column on a table, but they will not be enforced in Synapse. And you have to make sure that you specify the not enforced clause when you're defining them. And then additionally, the primary keys will only work as a non-clustered index. Typically in a SQL Server database, when you define a primary key, in a lot of cases, it will be your clustered index, meaning that the data in the database or in the table is physically arranged based on that primary key. But yeah, not in the case of Synapse. So this really presents an interesting scenario. If you do use these types of keys in Synapse dedicated SQL pools, and I'll show you why. An example here, if you look at the left, you can define a primary key. So we have a very simple table here with table ID being identified as our primary key. And so in making this definition, the query optimizer on the database will take that into consideration when executing queries. However, it is not going to check that it really is valid. So it's not enforcing that primary key. And by this, I mean, you can see through this example here, if we run a simple query on this table where we're selecting the table ID and account and then grouping by the table ID, what you would expect is, since we have two records with the table ID equal to 1, that we would get in the aggregate here, there would be 2 records with that count where the table ID is 1. And so this is the result set that you would expect to see from that query. However, in the Synapse dedicated SQL pool, when you actually run it, it is not enforcing that primary key on its own, since you as a user are left with the responsibility of enforcing that. It is just going to assume that that constraint has been enforced. And so it's going to assume that every value in that primary key column is indeed unique, and it's going to return results under that assumption. So here you can see it's assuming that these 2 records with ID 1 are indeed unique, even though we can tell that they're not. But since we told the database that it is, this is the actual result set that you're getting. So moving on to some other functionality, stored procedures. The dedicated pools do support stored procedures, but in a lot of cases, they work a little bit differently from the more traditional SQL Server. One of the primary ways is that in a SQL Server database, when you have a stored procedure that you create, the first time you execute it, it's going to be compiled, and that execution plan is going to be cached, and it'll reuse that same execution plan every subsequent time that you execute the stored procedure. But in the dedicated SQL pools, the code for the stored procedures are going to be parsed, translated, and optimized every time you execute it. And then the statements within that stored procedure are going to be distributed. So it runs a little bit differently behind the scenes. And then also within the stored procedures, we do have some limitations. So in a traditional SQL Server, you can take the output result set from a stored procedure and insert that into a table using an insert execute statement. But you can't do that with a dedicated SQL pool. Likewise, you can, with SQL Server, you could pass in a table valued parameter, but those are not supported in Synapse dedicated pools. Likewise, you don't have default values for any parameters. You have to explicitly define the value for the input parameters each time you call the stored procedure. And you can't encrypt the stored procedure in the dedicated pools like you can in SQL Server. And then some other functionality here, triggers. I don't know how many people have worked with triggers in more of a traditional relational database, but they are programmatic constructs that allow you to execute code either before, after, or instead of an insert, update, or delete statement. And then also you can create other types of triggers that'll run in response to DDL events. So things like creating tables and altering, dropping tables, things like that, or even in response to logon events. And so these triggers that you can create in regular SQL Server are, again, not supported at all within Synapse dedicated SQL pools. And then cursors are another construct that Synapse doesn't support. And those, again, really have more of a transactional focus that allows you to take a record set and loop through the records in that record set one at a time and perform certain operations. And then some of the syntax also related to update and delete statements is a little bit different between the two. So in standard T-SQL, you can write update statements, and delete statements would work in a very similar manner, where you can join multiple tables in the from clause, and the specific table that you want to update or delete from can be just referenced via a table alias. So you can see on the left-hand side, here's an example of that. We're declaring the table in our from clause and doing a join there, and then just referencing that first table A in the update statement itself, in the update clause. But you can't do that with the dedicated pools. So you have to specify the table that you're updating or that you're deleting in the appropriate clause at the start of the command. And then if you want to do any joins to that, you have to do that in the from clause and do those joins via a where clause, as you can see here on the right-hand side in this simple example. Let's see, and then actually, I guess I've already covered some of these in terms of the unsupported features. As I mentioned previously, triggers are not supported, cursors are not supported. And then one other thing that just in my time working with it that I've discovered is not officially supported are table valued functions. So I say that those aren't officially supported because you can still actually create and execute table valued functions. However, if you're working with your database in SQL Server Management Studio, you're not able to see those table valued functions anywhere. And so, yeah, if you can't see them, it makes them difficult to use. You kind of just have to know that they're there. So it's, yeah, I'd say by and large, they're generally not supported. And then also, if you're working with code in Visual Studio in a database project there, if you try and compile code that has a table valued function as part of your database project, your project will not compile because those table valued functions are not supported. All right, and that brings me to the end of my presentation. I do have some additional references here, just if you wanted to read more about any of these topics. And this slide deck has been uploaded as well to that shared folder. So are there any questions?
No questions, just excitement of quality of the presentation. Tyler, this is
Thank you.
This is excellent presentation.
Thank you.
Yeah, this was really good.
Thank you.
Yeah, thank you very much.
Yeah, thank you.
Yeah, you're welcome.
Thanks, Tyler.
You're welcome. All right, so if there are no questions, yeah, I guess can go ahead and sign off. I don't know, have you stopped recording, Lev?
Yes, just a second.
Okay.